Hello everyone! Today I'd like to introduce a brand new natural number puzzle. Some of you might be familiar with the puzzle Magic Square. Similarly, the inventor of this new puzzle has named it Woojong Square. It was created around the end of 2022 by Woojong Square, a Google and Apple app developer. He took inspiration from Magic Square and his own puzzle game called Woojong 3. While it may first look similar, it utilizes a completely different mathematical method. First, a quick reference to Magic Square, which is a square array puzzle where the sum of the numbers in every row, column, and main diagonal should be the same. You are looking at an example of a 4x4 magic square. In this case, the magic sum is 34. On the other hand, if you look at the 4x4 Woojong Square, 4 numbers that make up every row, column, and main diagonal must produce a unique addition equation. As shown here, addition equations are done perfectly in all 10 cases of rows, columns, and main diagonals. There are many more 4x4 Woojong squares than this. This example on the screen, being one of many, shows the most straightforward 4x4 Woojong square. Here's another example. As you can see, there are 4 rows, 4 columns, and 2 main diagonals, so the 4x4 version of Woojong Square generated 10 unique addition equations accurately. Another example, different from the last two. In the previous examples, all the addition equations formed an equation so that the sum of 2 numbers out of 4 numbers equals the sum of another 2 numbers. However, this example shows different types of equations so that the sum of 3 numbers out of 4 numbers equals the remaining other number. There are 4 such equations out of 10 equations here. Generally speaking, the n by n magic square exists in all cases where n is a natural number greater than or equal to 3. But Woojong Square cannot exist when n is odd. Assuming that the value of n times n is equal to s, numbers from 1 to s are necessary to produce a square array, and s should be an odd number because the odd n times the odd n is always an odd number. So, of the numbers from 1 to odd s needed in the n by n square array, the amount of odd numbers is always 1 more than the amount of even numbers, and naturally the total amount of odd numbers is always odd. One good example, as you can see in the figure, if n is 5, there are numbers from 1 to 25, which is 5 times 5. The amount of odds is 13, and the amount of evens is 12, aka the amount of odds is 1 more than the amount of evens. Importantly, the amount of odds will be 13, which is odd. With these configurations, it is impossible to establish addition equations in all 12 cases of the 5x5 square array because the amount of odds must be even. So Woojong Square cannot exist if n is odd. In the construction of the 6x6 square array, the numbers from 1 to 36, which is 6 times 6, come out. In other words, the total number of odd numbers is 18, which is the half of 36 and an even number, so there is a high possibility of the validity of the 6x6 Woojong Square. However, the most straightforward 6x6 square array, as you can see now, does not satisfy the correct condition. If you look at each row, it consists of 3 odds and 3 evens, so it is impossible to establish addition equations. Addition equations would only be possible if the number of odds is even in each row. Take a look at this legitimate 6x6 Woojong Square. It flawlessly shows 14 addition equations in every row, column, and main diagonal throughout the whole 6x6 square array. Does it look as magical as the 6x6 magic square? How about this one? It's a kind of dynamic variation of the 6x6 Woojong Square. Let's take a closer look. All of the addition equations here have 3 sides instead of 2 sides, so there are 3 expressions in each addition equation. Each case of 6 numbers is divided into 3 sides equally, and each side has 2 numbers, which looks like a legitimate variation. But would it be possible to build another legitimate 6x6 variation where some of the sides can have only 1 or 3 numbers? For the final example, you are looking at the 8x8 Woojong Square. 8 rows, 8 columns, and 2 main diagonals. A total of 18 addition equations are established correctly. Of course, the most straightforward 8x8 Woojong Square exists unlike the 6x6 square array. So in the n by n Woojong Square, where n is a multiple of 4, such as 4, 8, 12, 16, and so on, there is always the most straightforward Woojong Square, and there are many more variants in each case of the value n. On the other hand, when n is a different kind of even number, such as 6, 10, 14, 18, 22, and so on, the most straightforward Woojong Square is not possible, but it is assumed that there are many more Woojong Squares in that case, each case of the value n. A good example would be the legitimate 6x6 Woojong Square that I showed you earlier. However, in all cases where n is odd, there is never a Woojong Square. This is the final slide. Today's topic was a newly created natural number puzzle called Woojong Square. The magic square has many properties, variations, and classifications. Does Woojong Square have many of them too? I hope that those who are interested in this puzzle will participate and make good discoveries of their own. Some of these discoveries could be: how many 4x4 or 6x6 Woojong Squares exist? And does the most perfect 4x4 Woojong Square exist, just like the most perfect 4x4 magic square? Are there any good solutions to build 4x4 or 6x6 Woojong Square and beyond? Does any prime number Woojong Square exist too? The inventor of this puzzle, Woojong, has said, numeracy improvement can be a good starting point for people trying to get integrated to the STEM field. And fun natural number puzzles and games can be a good way to improve numeracy. So I hope that more people will pay great attention to the development of natural number puzzles and games. The puzzle Woojong Square and game app Woojong 3 in the Google and Apple App Store can be good examples. And Woojong is intending to publish more natural number puzzle games in the near future as well. Anyways, if I have another chance, I'll see you again with more puzzle game topics. Bye everyone!